Okay, welcome to Chapter 12, Part 1, Factorial Designs. Factorial designs is the next step after simple experiments. A factor just is an independent variable. Now, technically, it doesn't have to be a purely independent variable. It doesn't have to be manipulated to be a factor. So, for example, something that we might measure might be considered a factor as well. That's why we call it a factor instead of an independent variable. So factorial just means there's more than one of those independent variables. We use factorial designs normally when we're looking for a moderated hypothesis. So let's just remind you what that looks like. So factorial means that we're going to have more than one independent variable. So this would be an IV, this would be an IV, and this would be a DV. IV stands for independent variable, DV stands for dependent variable. Now, normally we're looking for this kind of a relationship, a moderated relationship. Now, you'll see that this is a moderated relationship because the first independent variable, let's make sure that this is going to work. Yep, the first independent variable, let's call that IV1. Let's see if we can do that. This first independent variable, IV1, is affecting the dependent variable, but the effect of that changes depending on another independent variable. So those independent variables are called factors in this case. This is a moderated hypothesis. IV1 affects the DV, but the effect of IV1 on the DV depends on IV2. It depends. So for example, the effect of independent variable 1, let's make independent variable 1 be hugging, right? And the dependent variable is happiness. So hugging affects happiness, but IV2 is scent of the person you're hugging. So IV1 affects IV2. Hugging affects your happiness, but the way it affects your happiness depends on, is moderated by the scent of that person. So if that person is stinky, your happiness goes down. If that person smells good, that happiness goes up. Okay? Now remember that a factorial design just means we have more than one factor, more than one independent variable. That's all that means. All right? So normally that means we're looking for a moderated hypothesis, but it could mean that we're actually looking for, or we have, whether we want it or not, something different. Okay, like this. This is not a moderated hypothesis. IV1 affects the DV, right? But IV2 also affects the DV. There's no it depends here. It's not a moderated hypothesis. This would still be a factorial design because we have more than one factor, more than one independent variable. But it would not indicate a moderated hypothesis. An IV, in this case, so let's do an example in this one. I think that stress affects your grades. I think that study time affects your grades. So I think that the more stress you have, the worse your grades. I think the more study time you have, the better the grades. But I don't think that the effect of stress on your grades depends on anything. I think just more stress equals worse grades. And I think more studying equals better grades. That's it. Just two factors that work independently. Now, this moderated design that you see up at the top, the way we test that is with a factorial analysis of variance. We use a factorial analysis of variance if the independent variables, if the factors are categorical and the dependent variable is continuous. We're only going to ever do factorial designs with categorical variables and continuous dependent variable, right? So to find whether or not we have a truly moderated hypothesis, a moderated effect, we would run a factorial analysis of variance, and we would specifically have to look for something called an interaction. The statistic we'd be looking for is an interaction. That interaction, if it's significant, it indicates a moderated design. However, if it's not significant, it does not indicate a moderated design. If, on the other hand, we have this thing at the bottom, this idea of stress and study time both affecting your grades, those would not indicate an interaction. Instead, it would be what's called two main effects. The main effects are the effect of each factor by itself on the dependent variable, nothing to do with how well they interact with each other.